test of NEET?
Yes, ma'am.
Okay, I'll discuss it. I'll just open the portal and I'll discuss it. Okay, let us start first. So, what is a projectile? Projectile is any body which, when it has an initial velocity, it moves under space influence under the influence of gravity. And in your regular class, we have seen the conditions of the projectile. When do we say that yes, projectile can this can be called as a projectile? I hope you remember x-axis separately, y-axis separately. So any body given an initial velocity moves freely in space under the influence of gravity is called a projectile. Then it says, this is an example which is given, a javelin, though a javelin throw that is there in Olympics. So it says that a javelin thrown by an athlete. So when a javelin is thrown, so it has this projectile motion, and a ball kicked from ground. So it has this. So we don't say this curved motion is called the projectile. You know, there are the conditions that has to be, those conditions have to be satisfied. So this says the path followed by a projectile is called its trajectory. So trajectory has different equations, and trajectory of a projectile is a parabola. This is important. And projectile is a two-dimensional motion. You know, one-dimensional motion, we have motion in a straight line, which we have done, which we have completed. Projectile motion is basically a two-dimensional motion. Now, a projectile, different variations and parameters in the projectile motion. So when we say a projectile, it is projected from a height h with a velocity u. So what all things are possible means, when I am saying this, this means that projectile is there on the ground. This is projected there. This is your main line, your y-axis, your x-axis. So from a height h, when this says, see, this is a projectile projected from a h height with velocity. Now this is from the ground. So in this case, we say this is the angular projection. And when from certain height it is thrown, so this is the projectile. That is, basically, this is the trajectory that is obtained. This is y-axis, this is the x-axis. This is the origin. So this is what is obtained, and this is the height here. So since this is making 0 degree, this is the parallel. So time taken by the projectile to reach the ground is, yes, Jesleen, what's the value of this? In case of horizontal, because I'm talking about horizontally, was this one. Under root 2h by g. Okay. This is under root 2h by g. This is the projectile's time period when it reaches the height back. Okay. Then time taken by the projectile to reach the ground does not depend upon the velocity of projection. You see in this formula, we do not have u present. So you will be having the time period straight away under root 2h by g. Coming to the horizontal range, it is like the distance getting multiplied by the time. So horizontal range is simply like your equation x is equal to ut. So your horizontal range will become u into t, and t is 2h by g. Okay. Then equation of trajectory. When we are talking about the trajectory equation, let's say this is some y. So y is equal to g by 2u square x squared, gx square by 2u square. This is the equation of trajectory. Now resultant velocity at any time when you have to calculate. So this is under root v square plus, see, this is your x part, x component, vx was v. So v square I've written. Your vy component was gt. So this will become g square and t square, correct? So under root v square plus g square t square. Gt was just your vy. Now see, when we are writing angle made by the resultant. So for angle made by the resultant, see, this tan beta, this is vy by vx. So Vy is gt by Vx is u or v, whatever is the velocity. I'll write it as ux, we took it as u, so u square only, because otherwise it will look like a final velocity, right? Now, velocity of the projectile on striking the ground. Here, see this gt, this gets converted into gh, because we use the equation, no, v square minus u square is equal to 2gh. So from here, when you're calculating the final velocity, this will be u square plus v square is going to be 2gh. So this will be under root 2gh. So these are the equations that we'll be using. So write it till here first, all these equations. Then we'll continue with the angular part. First, write down it till here. Done, ma'am. Done.
Yes, ma'am.
Okay, coming to a projectile projected with velocity u at an angle with the horizontal. So before this, we were discussing that if you have the projectile present horizontally, means the angle that is made with the horizontal, this is 0 degree. So when we are writing the projectile projected with some angles, two things you have to write here. Firstly, the equation of x-axis, and secondly, the equation of y-axis. So for x, you write it as u cos theta t. So this is your basically ux multiplied to the time. And for y, you write this as u sine theta t minus half g t square. So these are the two equations which you have. These are separately along x-axis and y-axis. because you have to resolve vectors, and after resolution of vectors, you're getting this. Now, equation of trajectory here is very long. This is x tan theta, y is equal to x tan theta. Now, minus g x square divided by 2u square cos square theta. Okay. Then this says that velocity of the projectile at any time t. Okay, so when you're calculating the velocity of the projectile at any time t, you can use these equations. So V velocity will be, see the velocity here is u cos theta. So it will be the square of it, u cos theta square plus. And then this equation will be u sine theta minus gt. Not this is for displacement. For velocity, it will be this only. See, this is gt, this is u sine theta. This is from the equation, first equation, v is equal to u plus at. So v is equal to u plus at from this. This is whole square. So this will be under root of this. Now, if the velocity makes angle beta with the horizontal, so when you're writing the tan beta for the direction, so straight away your tan beta will also be Vy divided by Vx, not Vu. Or here it will be V only because we are calculating the final velocity. So you are going to write U sine theta minus Gt divided by U cos theta. Coming to the horizontal range. Horizontal range R is equal to U square sine 2 theta divided by G. Now, for the maximum horizontal range, when can the horizontal range be maximum? When your theta is what? When can we have the horizontal range maximum? Theta, tell me the value for theta. Yes, you all have studied. When can we say the theta is maximum? Yes, Abir. Very good. It's 45 degrees. It's 45 degrees. So here when you're writing the maximum range, see 2 into theta. Yes, Jyobita, 45. So 2 into 45 will be 90. So 9 sine 90 will be 1. So it will be u square by g. And one important thing that you should know is time of ascent is equal to the time of descent. Okay. So the two times when you are going to write the whole, see, whole time period t is equal to 2u sine theta divided by g. So when you're going to take just the time of ascent or just the time of descent, it will be half of it. So it will be u sine theta by g. Okay. So all these things are these are the formula. Before going on to the question, this is question related to these equations of x and y separately, these two. This point for x and this point for y. So first write down these note points for this horizontal, not horizontal, angular projection. This part is your angular projection. Write this. Just a second, class. This window has closed. Let me reshare it. This question says the x and y coordinates of the particle at any time are 5t minus 2t square and y is equal to 10t. Now, where x and y are in meters and t is in seconds, the acceleration of the particle is asked at time t is equal to 2 seconds. So see, when you have the equation x is equal to 5t minus 2t square, so Vx is equal to dx over dt. Now, when you are differentiating this, so when you are differentiating this, so you will put the exact value of this 5t. Understood? Here, when you're solving this, that is 5t minus 2t whole square. You'll put the exact value as it is. So what will be it when you differentiate it? See, it will be 5 and from this side, it will be minus 4t. So this will be 5 minus 4t. This is your vxt. Okay. Now, when you're putting the value of this vxt, you will get the acceleration for the x-axis also. So what will be the acceleration? Ax. This will be differentiation of vx, means dx over dt. So 5 minus 40, when you'll differentiate it, 5 will become 0. So acceleration around x-axis, this will come 4 meter per second square. Now, when writing about y-axis, this is equal to 10t. It's given in the question. Both the equations are given. So this is equal to 10t. Again, when you will get vy, you will differentiate it dy over dt. Now, class, what will be the answer when you're differentiating it? 10t. So when you will differentiate it, you will get it 10. So for acceleration, you will differentiate this. So what will be the acceleration? When you're differentiating ay, what will be ay? Yes, what will be the value of ay? Vy is equal to 10. What is the value of ay? Yes, what is the value of ay? You don't know basic differentiation or integration. Yes, Jovita. Vy is equal to 10. What is ay? Differentiate 10 and tell me the answer. Yes, Abir. Differentiation of 10. Jesleen. Differentiation of 10. We'll not move forwards until you'll answer this. Jyotita, you're present in the class, or you've just connected it?
No, ma'am, I'm there.
Okay, Jesleen has answered. What about Abir and Jyotita? If you're not able to solve this, then you'll not be able to solve any questions of NEET. You have not revised differentiation, integration, anything. Abir, where is your answer? You know that when you differentiate a constant term, you'll get 0. So I think this equation also you don't know how to calculate. I wrote it, so now you know it. Otherwise, if I gave you this question by yourself, then you wouldn't have got the answer. Please revise differentiation and integration. Then only you'll be able to solve any question of NEET or your simple CBSE board exam, whatever you will be having, final annual exam in your school. Every chapter involves this. Now, when you're calculating the net resultant, one acceleration is 0, one acceleration is -4. So net acceleration, it will be -4 meter per second square. So this will be C option. Write the question and the solution.